All right, welcome to the lesson for multiplying a square root by itself. So we're going to start by looking at some simplification examples. So we're asked to simplify square root of 4 times square root of 4. Square root of 4 is 2, and then 2 times 2 is 4. All right, next one. Square root of 25, 5, 25. And the final one, well, before we move to the final one, let's draw some similarities. Both same number under radical. Both are perfect squares. Both the result is the number from under the radical. Okay? So here we had square root 4 and square root 4, so they're both 4s. 4 is a perfect square, so they're both perfect squares. And then the answer ends up being 4. 25. Both 25 are perfect squares, they're both the same number, and then we end up getting 25. So if the pattern follows, we should suspect to get an 81 here. So square root of 81 is 9. Square root of 81 is 9. 9 times 9 is 81. So far, our pattern is holding. So before we talk about why this is interesting, let's talk a little bit about why it's possible. So if we remember back to our squares, and we're going to use the square root of 81 times the square root of 81 as our example. And we said that equals 81. 81, if it represents an area, we would put it there. So we're going to say area equals 81. But we could also say the area equals the square root of 81 times the square root of 81. Right? And this seems redundant only because these are perfect squares. Redundant only because perfect squares. So what if I gave you an example where they're not perfect squares? Square root of 7 times square root of 7. How would we get the area? We can't simplify because they're not perfect. They're not perfect. But the pattern we saw earlier, we know that if they're both the same number, we can just trust that the result will be that number, even if these numbers aren't perfect. So the square root of 7 times the square root of 7 is 7. Right, so let's see a few more of these. All right, so let's make this the square root of 5 and this the square root of 5. Or actually, I don't know why I drew 5s here. Let's make these lucky 13s. So algebraically, what is the area? Algebraically, the area is square root of 5 times square root of 5. But again, these are not perfect. So I can't take the square roots of 5. But if I use the pattern, I know that this has to equal 5 because they're both 5. They're both under a radical and they're being multiplied together, because it means, yeah, the area here would be 5. Same thing over here. Area is equal to square root of 13 times square root of 13. I can't take the square root of 13 because it's not a perfect square. But the pattern, the area is equal to 5. The pattern, if I use the pattern, I know the answer is going to be 13. So the area is 13. All right, so before you move on to the handout, I just want to do a quick review of some of the things we've learned about square roots. Okay, so square root of 5 times square root of 5, square root of 14 plus square root of 14, square root of 6 minus square root of 6, and square root of 10 over square root of 10. Okay, so we've learned ways to deal with all of these. So we have all of the major operations: multiplication, addition, subtraction, and division, all with radicals. So we want to make sure we know how to deal with them when we see like radicals in each different operation. So looking just here, we just learned this one. So we know when we have the same number under the radical, that the result is just going to be the number under the radical. Okay, and these are simplifying problems. Simplify. All right, here's a little different, because to add radicals, I need like radicals. Okay, luckily these are both square root 14. I'm going to rewrite it like this though: 1 square root 14 plus 1 square root 14. So if I have one group of square root 14 plus another group of square root 14, in total I have 2 groups of square root 14. All right, same thing here. I need like terms for subtraction and addition. Okay? So I'm also going to rewrite this as 1 square root of 6 minus 1 square root of 6. So if I have one group of something and I take that group away, what am I left with? I'm left with 0 groups of that thing. So I have 0 groups of square root of 6. 0 times anything is 0, so we get 0. All right, and finally, square root of 10 divided by square root of 10. I can't take the square root of 10 because it's not a perfect square. I guess there are multiple ways to do this one. I'm just trying to think of the way that they want to see it done in the curriculum. So I guess there's 2 ways. I'll show both, because I guess both are fine. So we could extend it to one big radical. We get 10 over 10. And we know 10 over 10 is just going to reduce to 1. Square root of 1 is 1. Okay? The other way, yeah, so 1 square root of 10 divided by 1 square root of 10. How many groups of 1 square root 10 does it take to make 1 square root 10? The answer is 1, okay? So I guess this question is either asking from the top or bottom. It's both questions since the top and the bottom are the same. But yeah, generally when the top and the bottom are same in a fraction, it's equal to 1, okay? All right, good luck in the handout.